On number 2, we're first going to solve this equation algebraically. So we can get a common denominator of x minus 5, which would leave us with, in the numerator, since we can now ignore the denominators, 5 equals x minus 1x plus 5. So here, if 5 equals 5, since the x is crossed out, this is always true, so the solution is all real numbers. Except when you look at the original problem, x cannot be equal to 5. So you can say all real numbers, but x cannot be equal to 5. Graph the left side of the equation. So that means to sketch the graph of y equals just 5 over x minus 5. So we're just sketching the left side of the equation. We have a hyperbola with an asymptote at x equals 5 and a horizontal asymptote at y equals 0. So we have something like this. Now, describe its shape and its important features. We can see here that this is a hyperbola with an asymptote at x equals 5 and y equals 0. Now here it says to graph the right side of the equation on the same axis. So we're graphing the equation x over x minus 5 minus 1. Now we have, looks like a hyperbola, but since we have an x in the numerator, let's go ahead and just double check what that looks like. I'm going to graph both of these on the same axis. 5 over the quantity x minus 5 is the graph we just sketched. And then the right side of the equation is x over x minus 5, quantity x minus 5, x over the quantity x minus 5, and then minus 1. So let's see what those two graphs would look like side by side. So notice here it actually ends up being the same graph. Both of those give you the exact same graph. So we get the same graph. Explain how the solution you found in part A is related to the graph. So they're the same graph, which is why the two sides are always equal, all real numbers, except at the asymptote of x equals 5. So if we're describing this, we can say same graph, both are equal, except at the asymptote.